Namaste, I'm M. Bahadur Pokhrel. I'm going to teaching about the erythrocytic schizogony of plasmodium vivax. Erythrocytic schizogony of the plasmodium vivax occurs in RBC of men. This cycle and the figure as well as the description of this cycle are described slowly so that the student get more benefit after observing this video. Erythrocytic schizogony of plasmodium. Asexual cycle in men. Plasmodium is the digenetic parasites that completes their life cycle into the two different hosts, in which primary host is male. A primary host is a female Anopheles mosquito, but secondary or intermediate host is male. Male is the potential host, where three types of asexual cycle takes place. Pre-erythrocytic schizogony that occurs in the polygonal hepatic cell of the liver, whereas exoerythrocytic schizogony also occurs in the liver cells. During the pre-erythrocytic schizogony, sporozoids enter into the liver cell and multiply there by means of asexual schizogony process. After the completion of asexual schizogony. In the liver cell, they produce large number of cryptomerozoites. The result of pre-erythrocytic schizogony produce the large number of cryptomerozoites or cryptozoites. These cryptozoites release into the liver sinusoids. Cryptomerozoite again search the fresh liver cell and start the next schizogony cycle, expressed as the exoerythrocytic schizogony. During the period of exoerythrocytic schizogony inside the polygonal hepatic cell of the liver, they produce large number of metacryptozoites. These metacryptozoites are liberated into the liver sinusoids after rupturing the liver cells. Some of the metacryptozoites are changed into micro metacryptozoites and some are modified into macro metacryptozoites. Out of several micro metacryptozoites, some are released into the blood circulations. Some are released into the blood circulation and start to search the RBC or red blood corpuscles. When the micro metacryptozoites reaches the RBC cell in the blood plasma, they start to penetrate the RBC of men. After the complete penetrations inside the RBC, they establish in the cellular component of RBC. Parasites start to feed the cellular component of RBC and show the full growth and development. Hence, the parasite change into the rounded shaped trophozoites. The rounded shaped trophozoite start to digest the hemoglobin components of RBC together with the other cellular components. Hemoglobin, digestion and digestion of the other cellular component of RBC start to form the vacuoles. All the vacuoles are fused together to form a large central vacuole in our trophozoites. Formation of the large central vacuole at the center of trophozoite, nucleus shift towards the periphery, so that trophozoites looks like the gem of the ring. Trophozoite looks like the gem of the ring. Hence, such a trophozoite are clinically expressed as the signet ring trophozoite. Signet ring trophozoite. Now, the signet ring trophozoite rapidly digest the ingested food and becomes the irregular amoeboid shape. Becomes the irregular amoeboid shape. That means trophozoite looks like the amoeba. Hence, these stages are expressed as the amoeboid trophozoites. Amoeboid trophozoite gradually change into the another form of parasite that is called Schizogony. The parent nucleus of the Schizones divide repeatedly by the mitosis process to form 12 to 24 number of daughter nuclei. And each daughter nuclei is surrounded by protoplasmic mass due to the formation of vacuolar space irregularly inside the body of Schizones. Thus, each daughter nucleus with a vacuolated mass of the protoplasma together form the meroblast. After the formation of meroblast inside the Schizone, there are appearing of red eosinophilic granules in the protoplasmic mass of RBC outside the Schizones. These red eosinophilic granules looks like the red dot. Such a red dot are clinically expressed as the Erythrocytic granules. Thus, the Schizone parasite form the meroblast together with Erythrocytic granules. Finally, all the meroblasts are terminated into merozoites. And these merozoites are arranged like the petals in the flower, so that these stages are expressed as the rosette shape stage. All the merozoites are arranged at the periphery of RBC, and toxic pigment hemojoin are deposited at the center of RBC. Thus, the arrangement of merozoites in the periphery of RBC looks like the arrangement of petal in the flower, so that these stages are called rosette shape stage. After the full growth and development of merozoites inside the RBC cell of the male, it exerts the pressures so that RBC burst, and all the merozoites together with a toxic pigment hemojoin release into the blood plasma. These merozoites has no longer survived until they change into the gametocyte. Because these merozoites have the weak resistance power against the antibody of host. So that some merozoites enter in a fresh RBC and changes into the microgametocyte, whereas some merozoites change into the macrogametocyte after entering into the fresh RBC. Thus, there are formation of two gametocytes in a two different RBC. One kinds of the gametocyte have the clear cytoplasma and a smaller in size called microgametocyte. Whereas another gametocyte has the food-laden cytoplasma, comparatively large in size, dense mass of cytoplasma are expressed as the macrogametocyte. These gametocytes are still existing in the RBC of the male and cannot forward their life cycles until such merozoite occurring RBC is ingested by female Anopheles mosquito. That means after transfer of micro and macro gametocyte inside the body of female Anopheles mosquito, life cycle is being continued. In this way, large number of merozoites are released into the blood plasma of the human body, change into the micro and macro gametocyte. These are the infective stage for the female Anopheles mosquito. To the end of erythrocytic schizogony cycle of the plasmodium vivax, microgametocyte and macrogametocyte remains inside the RBC in a passive stage until the human blood cannot reach to the midgut of female Anopheles mosquito. In this way, the erythrocytic schizogony of the plasmodium vivax are ended. After observing this video in my YouTube channels, all the observer get more benefit from it, and I hope that all the observer, viewers, like, share, subscribe my video and YouTube channels to get such type of important teaching materials, teaching and learning materials, as well as all other funny activities in our next sessions. In this way, the life cycle of Plasmodium vivax are ended. Namaste, all of my viewers. Thank you.